screen?
Nampak.
Nampak, okay? Hari ini kita akan, today we'll discuss or do the SPSS for the topic of correlation and regression. Okay. Do you still remember what is correlation and regression, class? Do you still remember? Okay, basically correlation is about relationship, or the general term is association lah. Okay, and the regression is something that you need to do, which is in the form of model. Okay, you have the value of beta naught and beta 1 and so on. Depends on how many variables that you key in. Okay, first we are going to do the correlation, Wait, okay, this is basic pattern for the correlation. Either it's perfect or strong, positive or negative correlation. Okay, this one, we are going to do the percent correlation first, and then remember for the percent correlation is a normal distribution. Then this is a parametric statistical analysis. Okay, but this one not normal, so we go for the non-parametric. Spearman and Kendall is a non-parametric correlation. Right? Now, basically the percent coefficient correlation is between the range plus and minus 1. Okay, so everything you know already, right? Okay, this is the formula. Okay, now we are going to key in this data is about the advertising and sell. Now you key in this one first, class. You know how to key in, right? Do you know, class, how to key in?
Yes, Miss.
Okay, now key in the data first about the advertising and sales. Okay. For example, this one, I just ignore first lah. Okay. Alright, key in the data, declare first about the advertising and sales. Okay. Everyone, please open your SPSS. Do it on time. Don't delay class. Okay, done, key in. You just follow the data from the lecture note. Okay, since this is a scale measurement or interval ratio, so make sure the measurement is in scale. Okay, to do the percent correlation, you must use the scale measurement data. Okay, once you have declared this one, okay, no missing value, assume no missing value, so none and none value to key in. So go to the data view, then key in everything. Since this is 2 decimal places, so at the variable view, you put 2 decimal places. This one, 3 decimal places, just follow this one, 3 decimal places. Okay, and then you key in the data.
Okay, Miss. Done.
Done. All right. So once you have done, first, what you're going to do is, this one is you do it by manually, okay? For manually, actually, you need to find the x square and y square and xy, okay? And find all its sums. But now we are going to do it by using the SPSS, okay? What the assumption? Okay, remember, this is the assumption for the correlation. First, it must be related. Okay, check. This one done. Scale measurement. Yes, this one for the scale measurement. Your data is that normal? This one you need to find either your data is normal or not. Okay, based on the Shapiro weight. Since this is small data size, go to the Shapiro-Wilk, okay, statistic. And then the linearity and homoscedasticity, you can find it by using the scatter plot. Okay. All right. Where's the data? Okay. First, you go to the analyze, check the data either it's normal or not. Okay. And then go to descriptive, statistic, go to explore. Okay. Then check both the data here. Okay. And then for the statistic, descriptive, and then go to the plots. Okay, no need this one. Just go for the normality. You can choose them if you want. Okay, I just go faster today, class. We'll look at the table of Shapiro-Wilk statistic, and then click continue, and then click OK. Okay, now this is the output. Okay, since this is output, you look at the skewness and kurtosis. First, it will give you the how many valid missings and how many total of your observation of the data. Okay, the first table. Now, then this is descriptive. Since I click the button descriptive, so it gives you the table of descriptive, which is you can see the skewness and kurtosis is still in the range of plus minus 1. Okay, this one still in the range of plus minus 1, but look at the kurtosis, more than negative 3, more than the range of plus minus 3, the rule of thumb of kurtosis. This one quite not normal. Okay, the most important thing is focus on the Shapiro-Wilk. Since this is only how many data? 5 data, right? Small sample size. So we'll look at the Shapiro-Wilk statistic here. Okay. About the normal QQ plot, it's normal, okay, and so on down there. All right. Look at the normality. Since this is more than greater than 0.05, so meaning that both the advertising and sales data is normal. So you can go for the correlation, which is percent correlation for the normal distribution data. All right. Go to the analyze. Okay, descriptive. Sorry. Go to analyze and then go to the correlation. Correlate here. And then choose bivariate because this is between only between two variables. So you choose the bivariate. There are many partial, distances, and canonical. So we focus on the bivariate first, okay? Then click the bivariate. All right. Here for the bivariate, you choose both variable here. Okay. Choose person because this is parametric. Non-parametric is candle and Spurman. Remember that one. Okay. All right. To tell, like the significant ratio. All right. And then what else? Did not set to you. Choose the mean and standard deviation. Okay. This one is exclude pairwise. Let it be. And then continue. And then click OK. Okay. Now you can get this. Miss don't know how to. This one, right? I don't know. Nak besarkan diskon kelas. I think you can see, ya. Okay,
Boleh,
for
Miss.
the boleh nampak kan? Okay, now
Boleh,
look at the advertising. Between advertising and advertising, the person correlation is 1 lah, because this is same. Okay, perfectly 1 lah. Okay, perfectly correlation 1. Okay, but this one, you look at the between the two variable. This is like a metric, 2 times 2. Okay, 2 at the row, 2 at the column. So this is metric 2 by 2. Okay, and then cells here 0.8 to 9. It's quite strong, right? Okay, for the correlation 0.8 to 9, you can imagine the shape to be like this, almost like this. Okay, if one like this lah, quite perfectly strong. Okay, this one quite strong also. Okay, then here is 0.8 to 9. Okay, how about the significant to tell? Okay, this one. Since this is statistical analysis, so it must be less than 0.05 using 5% kan. So this one more than 0.05. So even this is quite strong, but this is insignificant strong relationship. Okay, insignificant. Dia tidak signifikan. Even dia tinggi, tapi dia tidak signifikan. Okay. Alright, that one for the first data. We're moving on with the second analysis. Okay. After this is done, I'm sorry if I'm too fast, class. I hope you can follow. Okay, still got the same like what Dr. Siti did it here. Okay, now we go for the experiment. Okay, this experiment for the interval also, interval or ratio data, and also for the ordinal data. Okay, now this is about the rank order data. Okay, this is the formula, and it is also between the range of plus minus 1. Okay, now this is skating competition between the team X and team Y. Okay, so this is the rank for the A, 3, but Y got 5. Okay, now you need to key in the data class about the team X and team Y. You key in first class because I haven't key in this one. I've key in yesterday, last today, but I didn't save it. Okay, this is team A. Team X. Okay, I just put like that, or you can put the underscore team X, and then we have a team underscore Y. Basically, when you are rushing class during the thesis or during the analysis, okay, once you do your project 1 and project 2, you just type the time team X and team Y, and then you label the right thing here. Okay, like this one, team, and then you have the space and type X, also like this. Okay, but here no decimal places, so you just put it no decimal places, and then no missing value also, but this one is the ordinal data. Okay, because it said to you this is rank order, so automatically this is measurement of ordinal data. Okay, for the data view, you just put in all the data. Sorry, this one, 1, 3, 4, 5, 6. Then key enough, please.
Okay, Miss.
Then, how about the rest? Are you keying the data or just watching what I'm doing? Watching.
Sudah, Miss.
Sudah? Okay, now, if you've done this one, okay, what you're going to do is do it the person correlation. Okay, this is a rank data. We assume that the data is not normal. Okay, so just go for the analyze, go to the correlate. Okay, by variate. Look, okay, choose the team X and team Y. Okay, and then not about the person. This one for the the experiment first. After that, you click the candle. You look at the output. Okay, right to check everything. So you will get the experiment output there. Okay, experiment output is 0.5. Okay, this is moderate relationship lah. Okay, because for the 0.5, you can imagine the scatter plot that you will get is something like this one. Okay, quite strong than this one. Okay, all right. Mana dia? Okay. Once you have this one, this is the percent correlation. Sorry, this is payment correlation, but this one, there is no, there is insignificant relationship because this is more than 0.05. So you can say that the relationship between team X and team Y is 0.5, R equals to 0.5 insignificant positive relationship. That is how you interpret the data. Okay. Now, since this one for the experiment, now look at the how about candle tower. Okay, you key in candle tower also, so you get the two table from candle tower and experiment. So this one. Okay, look this one for the for the candle town. Okay, the correlation coefficient is 0.2, meaning that this is quite low compared to the experiment, which is experiment is 0.5. Okay, but both of these relationship between Candle Town and between Team X and Team Y using the Candle Town and experiment respectively, it is insignificant relationship. Okay, all right. That one's done. Now we go for the categorical data. Okay, for the categorical data class, okay, you have two categorical data, which is between the gender here, boys and girls. Okay, directly look at this one. Between boys and girls, this is about the group. Okay, this is categorical data, boys and girls. And then the another categorical is about the choice. Okay, between the art and the science. Now you have the value here. How many people? How many students choose for the art degree at the same time it's boy? Also goes to the girls and the science degree here. Okay, so here, class, the null hypothesis said that no association. We said that no association, okay? Nothing that can be related between the groups and the choice. So meaning for the H, once the H null is no association, meaning that the H alternative, there is a association between the two variables. Okay, now this is just the recap. So here, before this, we use the terms of relationship because we have the direction, right? Either positive or negative relationship for the experiment, okay, for the person correlation. But this one, for the categorical data, we use the term of association, no direction, just the relationship, the general term of relationship, okay? We use the word association. Don't be confused this one when you have the question, okay? What is association? What is this relationship? You must remember what's the difference between these two words, okay? Now, here we are going to key in the data. Look at this one, class. You need to declare the value. 1 for boy, 2 for girls for the group variable here. And then for the student choice, you need to key in the value 1 for the art, and second, the two value there is for science. So you can see here, the group one means boy, okay? Still at the choice one, 1, 2, 1, 2, right? 1, 1. So 1, 1 for the 1, 1 matrix here is 25. Okay, same goes to the here. Boys again, 1 at the row 1, okay? Science second one, okay? The second value is 2. So the count number here, count is the frequency, how many students select all this one, okay? So the value is 50 and so on. Okay, I think you understand this one, class. Mathematics student will not have a problem with this. So you key in the data like this. You declare about the gender choice. Okay, this is nominal because categorical data. And then for the count here, the frequency, how many students select that one, either art and degree and between boy and girls. So this one is a scale. Okay, key in the data first, class. Then, but this one don't forget to key in the value 1 for boys, 2 for girls, and that one arts and science.
Done, Miss.
Done. Okay, this one done declared. How about the key in the data? Done sudah?
Sudah, Miss.
Sudah? Laju kamu. Wenfeng, can you follow the class? If you have problem, Wenfeng, you can PM me after this, okay? Not today, Wenfeng. Next week, probably can, okay? Okay, done, class?
Done.
Okay, done. Alright, now we are going to build the contingency table for the categorical data analysis. Okay, remember, for the contingency table, we need to state the weight cases because we are focused on the count, the frequency between the categorical data. You have the data of categorical here, right? The nominal data between the gender and the choice, but we are focusing on the count here, the frequency. That's why you need to weight the cases first. We choose the variable of count to build the contingency table so that Spss can read, can know already what are you going to do. Okay. Now go for the frequency. Go for the data button, and then you weight the cases. Okay, do not weight the cases. You choose weight cases by what is the frequency? Count is the frequency. So you choose count. Actually, there are many cases of weight cases, but this one for the contingency table, okay, we are going to weight the count variable here. Okay, and then click OK. See at the output, weight by count already. Now, this one, sorry, Miss berbagi tahu. This one for the candle and town, Spss also tell you this one is non-parametric correlation. Okay. Okay, now we are going to build the cross tab. We have friends here. Jangan lupa letak kehadiran ni kelas. Don't forget to type your attendance. Okay. Analyze. Okay, descriptive. We are going to build the contingency table, and then we use the cross tab. Okay. At the cross tab here, class, look this one. Based on the notes there, the row is about the group, and the column is about the choice. So you put the row is about the gender here, okay, group, or you can say group. I put gender there, and then choice I put at the column. Okay. And then for the statistic, don't forget to click the chi-square statistical analysis there. And then also for the nominal, this is nominal data, you choose the pi and Kramer's. Because from here, you can find how far the strength are. Okay, it can give you the value of the strength of this association. Okay, and then click continue. Wait, for the cell, for the cell here, don't forget to key in for the counts variable, key in the observed and key in the expected. Okay, how many expected value? Because rule of thumb, the expected value must be not less than 5. There is one of the assumption also. Okay, click continue and then click OK. Alright. So for the cross tab here, you can get the first of the summary table, okay, which is you have the valid, how many valid observation, and then keep missing cases here. Okay, since this is the metric class, you cross between the gender and choice, so there is 150 valid, even 20, 75 each, right, each row. Okay, but then you cross this one, you got 150, no missing cases. Okay, and then total is 150, 100%. So here, gender cross the choice, cross tabulation here. the real data, you count that there is a 25. For the science, is 50, so total 75. But using the cross tabulation, the expected count was 40, while the science is 35. Okay, this is correct because this is not less than 5. So you got you already done for the assumption in contingency table, which is using the rule of thumb cannot be less than 5. Okay, because the value of 5 is refer on the probability. I think you already studied about the statistic economy before in your first sem, maybe. You cannot less than 5 for each metric here. Okay, if you less than 5, meaning you are using the wrong metric. Okay, because this is related with the probability. Okay, all right. Same goes to the goal here between the art degree and the science degree to the girls. The expected count was 40 and 35 also. Okay, all right. Look at the chi-square. Look at the chi-square test here. Person chi-square test. Okay, the value or the significant value was 0.000, two-sided. Okay, so it can be said this one is less than 0.05, meaning that this statistical analysis is significant. Okay, you can say that it can be concluded that there is a significant association between the group or the gender here and the choice, as soon as the p-value is less than 0.001. Okay. Why we choose for the percent chi-square here class? Because percent chi-square here is to determine whether the categorical variable are independent or are related. Okay. Okay, remember, to build the contingency table here, we have three basic assumptions, which is the first, the data assume a random sample, okay, like we said before. And then there is independence between each observation. If you use this one, percent correlation independence. And then the expected frequency here, expected count, must be should be less than 5. Okay. So you can see or you can interpret the result here. The percent chi-square statistic is used to determine whether there is a relationship between two groups of gender and the student choice, which is between the art degree and the science degree. Okay, then the relationship is significant. Okay, meaning that you reject the rationale before. What's the rationale said? Before this, rationale said there is no association, right? So since this is significant relationship, so we reject the null hypothesis, we accept the alternative hypothesis, meaning that there is an association between the two variables, which is the group and the choice. Okay, now we go for the last one before we end this tutorial for today, which is about the okay, sorry, Miss Lupa, I forgot to discuss about the strength. Okay, as you can see at the output class, the table of pi and Kramers, it gives you the strength of 0.4. Okay, for the pi, it gives you negative 0.4. For the Kramers, is 0.4. So the strength is 0.4. Okay. So this is the strength of association between the two variables, only 0.4, not quite high. Okay. Consider this is moderate association. Now we go for the regression analysis. Okay. So you know what is your X, what is your Y, based on your research design, what are you going to do? So in the linear regression, you are going to find the best fit. Okay. like this is the LSL or the least square line method, ataupun in Malay we call this one is kuasa dua, kaedah kuasa dua terkecil. Okay, you square the value of the difference, okay, and then you plus everything here, you sum the squared differences. Okay, now remember there is a R square here, where the R square is the value of the correlation. Before this, in the person we have small letter r, right? So you square the value, so you get the coefficient of determination R square, which is, it is about the total explained variation divided with total variation. It doesn't explain you what not out of the data, but it explain you what was the data are. Okay, so the range is between 0 to 1. Okay, so you can uh, transform it or calculate it in terms of percent. If your R square is 0 point something, so you can say that how many percent that the total variation is explained. Okay, so this is example of data. Okay, now you need to key in this one, class. Just follow the true data. Miss already key in some of here, but I don't get the same output from this one. So we focus on this one, width and length. So you key in this one first. So then we'll do the regression analysis. Key in the data first, class. But this one. Okay, you key in the data of width and then length. Only one decimal places. No missing value and so on. So the measurement is scale. This is not the ordinal or nominal data. So you key in this one, 0.0, okay, 0.2, in everything. Okay, this is only times 2. If you can tell me, first. Sorry. Okay, then can for the weight, and then you go for the length. I hope you can see the screen. Okay, class, done key in the data?
Yes, Miss.
Okay, if you're done, okay, we go for the regression and then we go for the linear. Actually, before you choose this one, you need to see the normality first, class, because one of the assumption must be normal data. Okay, this is parametric statistical analysis. So you choose first. We look at the explore for both data here. Descriptive. Okay, you want to stem again. If you don't want, also can, and then go to the normal. Okay, look at the normal data. Okay, both are more than 0.05, meaning that this data is normal, and then you can go for the regression analysis. Go to the analyze button, okay, and then go to the regression, and then go to the linear. Okay, for dependent here is about the length. You choose the length variable, go to the dependent, and then the weight, go to the independent. Put it into the independent here. Okay, here you have a few methods for the regression, which is the stepwise, remove, backward, and forward. Okay, if you choose the enter method, meaning that everything, the independent that you choose, either significant or not significant, will be in the model. Okay, you can get one table which is include all the variable that you entered. Even there is not significant, also in the table. Okay, but if you choose the stepwise, okay, only this is the scenario of more than one independence variable. Okay, if you choose for the stepwise class, it only gives you the last model, which is contains all the significant variables. This is what we call stepwise method. Okay, if you choose the remove method, meaning that you are going to remove the variables, but before you choose the remove method, you must do the enter method first, and then you can do the remove method. Okay, now for backward and forward here, for forward, it will choose the variable which is give you the high correlation first until the high value of determination of coefficient, the R square. This one, backward method, it will exclude the variable which has the lowest correlation between the x and y variable here. Okay, get it, class? So basically, people will use this one stepwise, because stepwise method actually it is the combination of backward and forward. Okay, it choose the right combination or the right variable for your model, okay, for your y. Okay, meaning here it choose the highest correlation between x and y, and also exclude the lowest correlation between x and y. Okay, so here we focus on the enter method. It just have one variable here. Okay, enter. Then for the statistic, go to the button statistic. Okay, you click the estimate, model fit. Okay, estimate will give you the value of beta. Okay, and then model fit, and don't forget to click the descriptive button also. Okay, and then actually you need to find the Dublin-Watson also. Later, your for this lab class, you need to find the assumption for regression. I didn't explain this here, but there is one of the tasks for today lab. Okay, one of that is you need to find the Dublin-Watson, which is Dublin-Watson is about the residual inversion. So there is one of the assumption that you need to find in regression. Okay, you can Google it. How many and what is the assumption for the regression actually? Okay, and then click continue. Okay. Okay, and then click OK. Right. Here you will have the descriptive table, mean and standard deviation. Okay, now you can see here the percent correlation between the length and width. Length and width here is 0.9. Quite high, right? Almost perfect correlation. So plus this is between width and length here. This is significant relationship. Okay, positive significant relationship. Using the enter method, okay, the R square here is 0.92. After you square the value of R here, you can get 0.92, meaning there is 92% of the variation in the measure length is explained by the weight. Okay, meaning that the weight variable here contribute to this model towards the y variable here, the length. Okay, now this is the ANOVA table. Okay, see here the value for the F value here is significant. Okay, this indicating that using the model is better than guessing the mean. The mean, sorry, the mean here. Okay, meaning that you are doing the right model. Okay, then ANOVA here, it will relate with your hypothesis. Okay, and then look at the coefficient table, the unstandardized coefficient here, the beta, the constant here, beta naught is 5. And then the weight here, you can see positive value, right? Meaning that when the weight increases, so you can predict that the weight also increases. Okay, and both the variable here is significant. Okay, so you can say that I think there's in your lesson note here. Okay, this is 92% explained. Okay, so you can say that. Okay, this is the model. Okay, so 5 is the constant plus then 0.208 here, and then times any value of the length, the weight, sorry, you want, and then you can predict the length, how many length. Okay, so here the remainder correlation coefficient. If you multiply each value variable by a positive constant, the correlation coefficient will not change. Okay, and then in same, you adding a constant or you interchange value between x and y. Okay, it's not the value of correlation coefficient will not change. Okay, remember correlation is not causation, but for regression it can be causation if you have to check all the assumption is done and correctly. So we can say that all the variable here in the model can be the causation for the y dependent variable that you use. Okay. Then do not extrapolate a fitted line, such as the least square line, outside the range of the data. For example, here, the linear relationship may not hold there. Okay, the value of the when range from 0 to 3.8. Okay, still remember the data between 0 until 3.8. So we cannot predict that the length for any value more than 3.8. Okay, it just gives you the data or predict the data depends on your data only, not out of this one. Okay, right. I think you understand already, class. Okay, if you have a problem, you look back at the recorded data and then do this one. Okay, your task for this lab, okay, before we end this one, your task for the lab is you need to find what are the assumptions for the regression, and then do it in one folder of Word first, and then convert to the PDF and send to the Spss lab email. Okay, understand? Got it, class? So your task is find the assumption of regression using the data before. About the length and the length, okay? Bumi baru masuk. Okay, and then submit this one before next. Okay. All right. Next week is the midterm sem break, so you have 1 week. Okay, and then a week after the sem break is the midterm week. So you will not have the lab, but you will have the lecture. Okay, and then the third one between 21 until 26. Okay, so you need to submit it before due 20 lah. Okay, due 20 of December. Okay. Right. Okay, class, understand? Any question? If no, then you can leave. All right. Thank you. Assalamualaikum.
Thank you, Miss.
Thank you,
Alright.
Miss. Waalaikumsalam.